6 of you back in the room. I'll hold on a couple of minutes. Sorry about all of that. Something must have gone wrong at my end with my internet. 6 in the room. I'll just hang on to see if the other 4 arrive. Yeah, another minute or so. Then we'll go through it really quick. Then we'll be done. I'm really sorry about that. Seven or 8 of you. I think there were 10 for most of what we were doing before. I'll hang on a small moment more, but of course people can always watch back if they join late. So I'll just wait one moment more and then we'll go through things really quickly. We're up to 9. I'm going to assume the 10th will arrive imminently. I'll start now. So I'll just adjust my camera, which gives people a bit more time as well. Right, and yeah, if anyone joins late, they can always look back. I'm really sorry about that. We'll just press on so we get the lesson finished. Question 1 said this, and I'm reading beyond the bold bit. It says, there are 2 types of traditional transformer, step up and step down. Describe the similarities and differences between a step up transformer and a step down transformer. You should include details of construction, including materials used, the effect the transformer has on the output potential difference, and you should not draw a diagram. Well, let's take those point by point. Similarities and differences, construction and effect. So I would say the construction, it's all about the similarities more or less. I'm not going to write this as a piece of prose. I'm going to give you bullet points and just check if your bits are in there. So under similarities, I would say a good answer would say that all transformers have a primary coil and indeed a secondary coil. And they have an iron core. These, remember, are similarities. Well, let's go to the second bullet point. So that's construction, the similarities in the construction. There are different ways you could have laid this out and different orders you could have taken this in, but let's also talk now about the similarities on the output potential difference. Actually, no, I'm going to do it this way. I'm going to do differences now. And the key difference in terms of construction is that, and you could phrase this in a number of ways, but in the step up, there are more coils on secondary. And step down, more coils on primary. So that's in terms of construction, but let's go back to similarities and differences, although I think probably only differences in terms of output PD. So more differences in terms of the output PD. Step up, well, they increase the PD outwards. the output one, whereas step down, they decrease the potential difference output. And as far as I can see, as long as your answer has those things, it's probably getting 6 marks. We've stuck very tightly to what the question's asked us. It's asked us similarities and differences in construction and the effect the transformer has on the output potential difference. I can't think there's anything more we need to add. So on to question 2. And yes, quite some retrieval for some of you from stuff from last year. So I'm going to read the whole thing. It's just a good habit to have. The current in a circuit depends on the potential difference provided by the cells and the total resistance of the circuit. And in part A, we're asked to do this. Using the correct circuit symbols, draw a diagram to show how you would connect 1.5 volt cells together to give a potential difference of 6 volts. Bit of a strange question, but it just after 4 cells connected together, because if each one is 1.5, it's 1.5 plus 1.5, that's 3, plus another 1.5, that's 4.5, plus another 1.5 is 6. You're just looking for 4 cells connected together, all pointing the same way. And that was worth 2 marks. I'm not quite sure how you split the marks, but that's worth 2 marks. Question B. Figure 1 shows a circuit containing an 18-volt battery. 2 resistors, X and Y, are connected in series. X has a resistance of 3 ohms, and there is a current of 2 amps in X. Calculate the potential difference across X. Well, that relied on remembering this equation. V equals IR. It's probably the most useful equation in all of electrical physics. Well, let's put the numbers where we know them. So we know that across X only there's a resistance of 3. So where R was, there'd be 3. There's a current flowing of 2 amps. So the potential difference across X is 2 times 3. In other words, V equals 6 volts. Well done if you got that. Calculate the potential difference across Y. Now, conceivably, there's more than one way you can do this. I think the most straightforward way just relies on you remembering how circuits work. So there's 18 volts being produced by this battery, and it needs to get used up by these 2. We have just worked out this has 6 volts being used up. And I often compared it to pizzas on a delivery route. 6 pizzas were delivered there. The other pizzas have to be delivered to Y. So the calculation, as far as it goes, is that you're doing 18, take away the 6 volts that have already been used, and that reveals 12 volts to be the answer. So the potential difference across Y is 12 volts. Now to calculate the total resistance of X and Y, again, there's actually more than one way you can get to the answer, but probably the most straightforward, direct way is that we know the total potential difference and we know the total current. So we can reuse this equation. There are other ways of doing this, but we can reuse this equation. We're trying to find the total resistance. The total voltage, the total potential difference was 18. The total current is 2. Therefore, R equals 18 divided by 2. Total resistance in that circuit, 9 ohms. Well done if you got that. So each of these has been 2, 2, 2, and 2. The question continues though. Figure 2 shows a transformer. An 18-volt battery could not be used as the input of a transformer. Explain why. Well, if you were listening right at the beginning of the lesson, I did make reference to this. Batteries produce DC, so a good answer here is saying, explain why it couldn't be used. Batteries produce DC. I think that gets 1 mark, and then we need to explain why that means it can't be used. transformers need AC. Now I suspect that's enough for the mark. We could go into the detail of why they need AC, because they need to create a changing magnetic field, but I doubt we need it for 2 marks. I think that will be enough. If you put extra, great, but I think that's enough for that. Now this last one a little bit unfair because I haven't given you an equation that you need for this, but there is a way, and the clue is right here. A transformer is 100% efficient. That is suggesting whenever we talk efficiency, we can dip into the world of energy and of power. Calculate the output potential difference for the transformer shown in figure 2. There were other clues because the question gave us currents, so something with the symbol I, and it gave us potential differences, so something with the symbol V. So there's those 2 clues, and there's the clue that we're looking in the world of energy or of power. Well, let's remember that there is an equation P equals VI. So let's work out how much power was going in on the primary side of the circuit. So on the primary side, P equals VI. And in this case, that was a voltage of 18 times by a current of 2. There was 36 watts of power in that primary circuit. Well, we're told that the transformer is 100% efficient. So if 36 watts are in this circuit, 36 watts have to transfer into this second circuit. It's the law of conservation of energy. So over here we can say P equals VI. And in this case, we know that P is 36. We know that the voltage from the question is 12 times by I. And I'm just going to have to write underneath the rest of the working, but I would therefore equal 36 divided by 12. In other words, it equals 3. Really well done if you got that. The output current is 3 amps. Right, I will just turn this around and say my goodbyes. Thank you to you 10 so much for bearing with me through all of that. Tomorrow we have a lesson and it's the later slot, not the very early morning one. So it's at 12:25 tomorrow. What would have been lesson 4? So you can tune in from 12:15. I will send after this, maybe within the hour after this, I'll send you the work to print out. And actually, I suspect tomorrow will be our last one. I'll say some more on that towards the end. If you want to wrap things up in the next week with, I don't know, a bumper physics quiz or something like that, I'd be absolutely open to that. But tomorrow will be the last lesson I need to complete the content. And maybe it's the sensible place to start. We'll see tomorrow anyway. For now, though, have a lovely evening. Have a lovely rest of your day. Look out for my email because I'll send you the things to print out. And we'll learn one last thing about transformers tomorrow. So thank you very much for bearing with me, and bye for now.